Alright, so here's my AI final project. To do it, I use TensorFlow and Keras libraries, and I guess it works by using a convolution neural network. And so basically the idea here is it picks out parts of the image and analyzes them to see if it can decide if they're important or not, and then use that in the eventual analysis of it. I still don't fully understand it, but I do think it's pretty cool from what I have gleaned. So yeah, here's like another picture. It's taken just like the ear on the bear, and then it breaks it down into the pixels, and then over those pixels, it puts a filter of its own map, and kind of comparing those results, it builds up its final project there. And then it does this in different they're called layers, but some are based on color or just like the outline of the image. And so it uses all those and makes the different maps and then kind of compares them all together. And then to feed it in, this is a process called flattening, where it takes the number of all those pixels and puts them into a 1x9 that can just be entered in, and we get our output. So to do the project here, I was started with the pre-processing for the images, where we get the images all scaled and ready to go, send them in, use this function to send it to the right library, and that all comes from the Keras website. You got like data pre-processing, and it kind of just tells you how to do everything, how to use the function here. So yeah, we do that, and then we do the test image data as well, training set and test set, and then see it gets all the images and it separates them into classes based on the folders they're set up in here. And then after that, and then we build our model, and this is also from the Keras website. A few different models that you can choose from. I'm using sequential. And then the first layer is called in this process here, is called the convolution layer. So we're building that one first, and we're using the activation ReLU to do it. Keras offers a few different ones of these. Yeah, I was doing that, and then doing it a couple times just helps increase accuracy. So I tried that out, added a few more, and best I could get up to was about 75% accuracy by changing the different activations and number of times it did it. So this is another layer, drop out, and then the flattening process, and then we run it through our actual artificial intelligence to have it analyze all that data and see what is actually useful and what's not. And then we get our output and compile the result. So then here the epochs are actually doing that. It's as it's running through and testing the data. And I do that 32 times here. And it does tell you right over here about how good it did. So it starts off less than 50%, makes a big jump. And then it usually bounces around high 60s, low 70s for the rest of it, just slightly getting better. And this one ended on 75 exactly. Pretty easy one. And so the index is, this is how it will label them. One, just this first daisy picture here, pretty easy one. And so the index is, this is how it will label them. And then as you can see, this result was daisy. And then it printed out daisy. But so let's try some different ones. I picked a few that might be kind of harder. This one's just like a wallpaper. So we'll see. And I guess we'll start with the sunflower just to get it something different too. And we'll do the one with sunglasses. So we just change the name here to the name picture. And we'll run that here.
There it is. So yeah, came back with one there and sunflower. So it did indeed predict it correct. Kind of fun. I like it. Plan to kind of play with it a little bit more, try out a few of these different activation routines and different ways to send it through hidden layers, the output layer, see what I can come up with. But yeah, thanks.